In this video I'm going to show you a piece of code that was written by one of the students of Design a CPU. His name's Timothy Morgan and he's helped me out quite a bit with lots of great ideas on digital design and also writing code. He has gone ahead and built his own machine, which is based loosely on the machine which I cover in my online courses. So thank you very much, Timothy, and I'm going to show everyone the work that you have done here. So I'm going to start off by looking at the actual code. So I'm not going to talk over it in a lot of detail. I'm just going to have a little quick flick through just to show you. Now, the great thing about the code is that it uses all of the directives that I have generated in the assembler. So for example, you can see here it's got the EQU directives here, and if you head down to the bottom, it has the other directives, which are the DC, that's define constant, and DS, define storage. So all of these are being used within the program. Now, as I said, I'm not going to go through the details of the program, but you can see it takes in two hex numbers and adds them together and puts the answer on the screen. So we will see that working. But I just wanted to quickly flick through just to show that it's using all of the stuff that we've learned in the Design a CPU 2 course. So for example, it's got the jump to subroutine for printing characters, so it heads off to the ROM to pick out the jump to subroutine, and it prints the characters from that subroutine and then returns control back to the program. And you can see also it has the constructs here for the labels, so we're using labels throughout. And you can see that there's quite a few of the commands that we've generated. Now, I don't have any of the kind of more kind of exotic commands that we actually have available to us. So I've still to generate some more interesting code with those more kind of exotic commands. And the kind of thing I'm looking at is writing stuff with arrays and being able to access elements within arrays. So that's something that I'm working on just now, and I'm going to add into the Design a CPU 2 course. But it's got lots and lots of the basic commands which I have available, or we have available to us within our assembly language. So it's a nice and mid-range complicated piece of code that uses all or lots of the constructs that we have generated in the assembler. So that's the code there. Now I will go ahead and assemble this just to show you it does actually work. So that's the assembler here, and when I type in run, I'll show you the assembled code. So this is the assembled code here. Now I've got rid of all of the other stuff that I had originally in here, okay? I was using that just for testing purposes. So this is all of the code here, and it's by far the largest program that I have seen so far on the CPU. So now what we can do is we can load that into the CPU. In fact, I'll clear it off first. Clear out what's already there, reset, and I'll load the values in. Okay, so that's that one there. Okay, so that's the program loaded in, and it's all ready to go. So what we can do is we can put in two hex numbers. So I'll just put in just 1, 2, A4, and I could put in 3, 2, 4, B5. Okay, so they're just two random numbers that I've put in. What I'll do is I'll zoom in so you can see it a bit better. Okay, so that's the numbers entered in, and we'll just click run, and we'll see this thing running up. Now it's going to run a little bit slower because obviously I'm recording this, but you can see it is actually running through the code, and very soon it will start printing out the actual output here. Now you'll see that obviously it doesn't run very fast, but as I've mentioned before, that's not the point. The point is to use it as a learning tool. So as long as it's fast enough for us to be able to see code actually operating, then that's all we're really interested in. So let me move my face here out of the way. So you can see here it's working through and just typing out the values, the actual language constructs for the addition. Now what I might do is just pause this here and I'll speed up. In fact, I won't. I'll just let it run because it isn't too long for it to run up. And as I said, the nice thing about this is that not only does the code assemble okay on the assembler, which is a big thing. The assembler is quite a complicated bit of code, but after having assembled, it will then again it will run perfectly on the machine. And as I said, Timothy, he has got this running on a copy of this machine, and he's got it running on his own machine. In fact, I think he's had that running in his own machine for several weeks, if not a couple of months now. So that's the two values that it read in. It'll now go ahead and it'll do the addition. Now, maybe not the most exciting thing, but you can see here quite easily how this could be adjusted to do the multiplication, division and subtraction. So it could act like a little calculator. Also, I have the possibility of, rather than typing everything all in at once, to actually typing one in at a time and for the keyboard to be continually pulled. And in fact, Timothy, he's gone ahead and he's already implemented that. And he showed us a method of doing it. So I'm going to give that a go as well and see if I can implement that possibly today. So there you go. That's worked through our summation, and that's the summation of those two numbers. Now, if you were to head into the RAM, you could see the contents of the RAM. Here we've got the original code here, and we're going to have this extra information here. So this extra information has been loaded up using the EQU commands in order to put the all of the ASCII values and generate all the ASCII values and put them all in memory. So that's all for this video. Just a big shout out and a big thanks to Timothy for helping me get that together. It's a really nifty bit of code, and it just shows that the assembler and the CPU is really working quite well. So thank you. I'll catch you on the next video. Goodbye.